That will not go to the cloud anymore. It will just stay locally on your mobile phone using very little energy compared to what's happening today.
We found out is that even if you have a model like 2 billion parameters, that this can work. You can have an interaction between two voices that talk about a specific topic, and that sounds very realistic.
Welcome to We Talk IoT, where we explore the ideas and impact behind AI-driven tech of the future and how data creates real business opportunities. To stay ahead of the innovation curve, subscribe to our newsletters on the Avnet Silica website. I am your host, Ruth Haydock. While ChatGPT and similar services dominate headlines, a growing number of engineers are embedding AI directly into hardware, from conference room systems to industrial ovens. But why choose local processing over cloud services? The answer lies in three critical factors: data privacy, connectivity independence, and cost control. My guests today are Michaël Uyttersprot from Avnet Silica and Cedric Vincent from Tria. And together we will explore the technical challenges of cramming internet-scale knowledge into embedded systems, examine real-world applications that are already working today, and we will discuss which hardware platforms deliver the best performance. So let's dive right in. Welcome to the show, Michaël and Cedric. I'm really glad to have you today. How are you?
Thank you, Ruth. I'm doing well, thank you.
Thank you for the invitation. Looking forward to discuss a large language model with you.
Would you like the opportunity, both of you, to introduce yourselves? Michaël, maybe we start with you. What is it that you do?
The topic that I'm focused on within Avnet Silica, so we are a distributor of electronic components. My focus is on artificial intelligence. I started with this topic already more than 20 years ago from university when it was not popular that time. I support customers, but also support the company in going to the direction that we want for the future with artificial intelligence.
Terrific. Cedric?
So I'm Cedric Vincent. I'm working for Tria Technologies. With my team, we are specialized in application development for compute modules. We are developing compute modules based on NXP processors, Qualcomm processors. And what we do with my team is to put some software on these modules, but to try to show a bit the future. So basically, not sticking that with what we can do today, really try to embrace what we can implement with the next generation of hardware. For instance, if we talk about Qualcomm, with the new possibilities that are with these processors, thanks to the neural processing unit, we are trying to show customers, okay, what's next and what could we implement within that specific piece of hardware which comes with Qualcomm processors. And of course, one of these things are large language models.
Mm-hmm. Fantastic. To start us off, Michaël, what is so special about large language models?
Well, maybe it's good to go back a bit into history, I would say, and especially if we take a look to what has been developed by OpenAI with ChatGPT, and if we take a look to specifically GPT-2, this was in fact a game changer, because what they implemented was a kind of large language model, was not that big, but bigger than what they did before, because it was not a first language model of 1.5 billion parameters. And what they found out is that the usage that you have with this model was completely different than what you had to do in the past. So before large language models, you had to train a model to have a specific task, for example, to translate a text. But if you want to do summarization or any other kind of task, you need to create a new kind of model, retrain it, new kind of data. So this makes it more complex if you want to change something. But with GPT-2, they found out that if you have trained this model, that you can have a prompt like translate this English text to French, summarize this article in one sentence or create a story, that this can be done with a prompt. And in fact, you do not need to retrain the model. it's already inside the model that you have this implementation. So the model could change its behavior just by changing the input text, so what we call the context, without retraining. This was a game changer. It was the first general purpose transformer-based language model. And so what developers also realized is that the context can be in fact a control mechanism. That means, and this is how they implemented it since GPT-3, that means that you have in-context learning where you can say, for example, those are 3 examples, behave now the same based on those examples.
Okay.
And this is something that made a very big difference if you compare what you had to do by retraining in the past, having new data sets. In fact, because of GPT-2 and then the follow-up GPT versions where you have in-context learning, this made a big, big difference.
Okay. And now with these large language models do need a lot of storage, a lot of power to run on machines that are usually in the cloud. And now we're talking about you have been testing local LLMs could work on embedded devices. Why did you start on this journey?
It's a good question. Well, there are several reasons. One of them is because we saw more and more interest from our customers. Maybe because of the reasons that you already mentioned, like privacy, cost reduction, so to run AI locally. In addition, we also wanted to find out, can this really work? Like running large language models on embedded devices, is this feasible? So what we did is we started with some internal testing. We also created some applications. Together with Cedric, we developed like a telephone box where you were able to talk with an avatar and call back to the past and the future. Of course, this is nice to find out how things are working. But in addition, we also did investigation on what we call small language models between 1 and 10 billion parameters. Can you create, for example, like what Google developed, a Google Notebook LM, the audio podcast implementation? So you have 2 voices that talk to each other about a specific topic. So that's how it's working. So with this application, so you upload a document on Google Notebook LM, or you upload a link of a website, and 2 voices talk to each other, have an interaction, a discussion about that topic.
Okay.
So we
This
try
is not
to...
what's happening here. These are all real life people.
This is real life. Exactly. Yeah. So we did some tests. We took hardware like with AMD. We also tested with NXP devices like i.MX95. And what we found out is that even if you have a model like 2 billion parameters, that this can work. You can have an interaction between 2 voices that talk about a specific topic, and that sounds very realistic. And this is one of the starting points for us to continue more on this and to have engagement with customers and to work on projects with customers.
Speaking of customers, Cedric, is this something that you are also noticing, this increased customer interest? What do you think is driving this demand in addition to what Michaël just mentioned?
Actually, what's happening right now, it's not so much about the large language model like ChatGPT, that there is some interest. Because ultimately, this type of use case, so you talk with a model and you get some answers, can use some database to give you these answers. But where we see more interest in the industry right now, it's about vision large language model, which is kind of a derivative of the original ChatGPT. You can see that already on your mobile phone. Like sometimes I'm using that when I'm cooking, like I'm taking a picture of a vegetable. I'm not quite sure what it is because I get that in one of these boxes. Anyway.
Okay, I understand what you mean.
And then I just take a picture of that and it's telling me, okay, this vegetable is this and you can cook it this way. But where it gets interesting in an industrial context is like we can run this type of model as well on embedded device. And you can use that for safety purpose, for instance, like on a shop floor in an industry that you want to check if everybody is wearing hard hats, for instance. In the past, you could have done that with what I'm going to call regular computer vision, but you would have needed to get a lot of data, like a lot of pictures of people basically wearing hard hats, and then you train a model. But what Michael already explained, thanks to generative AI and vision large language model, what you can do today is just explain the model, okay, please look that everybody on that picture is wearing a hard hat. And if someone is not actually doing it, please make sure that you tag that and I get an alarm on my system. So that's one thing that is definitely triggering a lot of interest for a lot of customers, that ability to have AI models that you can reconfigure very easily to a specific task, and including computer vision. Another use case that is triggering a lot of interest is OCR, because in the past we already had models for OCR, like it's nothing new. But the quality that we can reach today with a large language model you can run on embedded devices that are developed by small companies like IBM, for instance, by some other Chinese company that I will not mention here, they reach a level of quality even for unstructured documents with handwriting and everything, which is absolutely crazy. And it's where we see a lot of interest as well coming from customers. They can use this type of models on processors like 95 on our smart modules, or on Qualcomm if you need a bit more processing power, and the time between the moment you do the request and you get actually the document is super critical for you. Most of the interest is, it's kind of at this crossroad between computer vision and large language model. And we see more and more interest in that specific field today coming from our customers.
Interesting. Now my mind goes into all different kinds of directions. I, of course, want to know more about the real world applications and especially the OCR example you just mentioned. But I think we also should talk about a little bit of technical deep dive at this point, where how you make this possible. You mentioned you tested different boards on different applications. What are your findings here? Can you walk us through some of this?
Yeah, of course. So the running, like when Michael was talking about the size of the model, like it's billion parameters, it's a lot. You should imagine it's a lot of little dials that you need to move to get to the solution of what you put as an input, like is it your voice, is it some text, is it some image? And then you can explain, like as the user, you can move some of these dials with the context, and then everything, somehow the magic happens. If you look at the original paper, the guy who wrote it, it was, so the name of our architecture, it's Transformer. And one of the sentence was like, it works extremely well, but to be honest, we don't really know why. And it's a kind of, and that's why some people were scared about them anyway. And so you have all these parameters, but I know from a technical standpoint, these parameters, how we code them, it's like with big numbers. And these big numbers, they are taking a lot of space in the memory of the compute module. And the magic to make this run on embedded device, it's basically to cut these numbers, to reduce the size. And we can do that very well. And there are very good algorithms actually to take like these, like, I don't know, like 8 billion parameters models, and to shrink the size of the model by reducing the size of the way we encode these numbers.
Okay.
By doing that, we can actually run that on very small microprocessors. Just by doing that shrinking of a model, we can run that on smaller processors like the i.MX95, QCS6490, and run it quite fast, actually, and fast enough that it's actually usable for customers.
Okay.
That's quite interesting indeed. And it's like what Cedric mentioned, there are several techniques like quantisation, for example, where it's a kind of compression, but you can keep the accuracy quite high, even like 95, close to 100%, and which is good enough for many applications. Also, Cedric, like, for example, we have a mixture of experts. So this is a technique that you select one part of the model. So it's also kind of shrinking down what you use of the model. And the expert is, for example, focused on mathematics, or another one of language, for example. But this is all in the same model, but you use only a small part of it. And those are the things that we try to find out if we use those models on embedded devices. What can you use to make it efficient and run it fast on the processing devices that we target, for example, like with TMD or NXP?
when I try to now reverse this logic of now you're fitting something that has been out there, the large language model, onto small embedded services. Now, my question would be, why not use that intelligence to make the large language models run more efficiently? Would that also work, or are we losing use cases or scenarios?
You still lose in accuracy. So
Okay.
basically, there is no miracle. If you reduce the size of something, at some point, there is a loss in terms of quality of the output. You can balance that very well. And there are a lot of people that have been working for years to make sure that it's not too noticeable when you're using the model. But still.
Okay. Got it.
But of course, some techniques they use in higher end models, like mixture of experts. This is used also in the bigger models, but quantization, this is more sensitive. On GPUs, you will not do this kind of compression. But yeah, this is something, you see that the evolution of the models improve. And this also helps by reducing the amount of the modules or the number of parameters and to speed up the models, for example.
And coming back to real world applications, you are now testing what is possible with these compressed and local language models, correct?
It's absolutely correct. It's what we have been running already from the beginning, because that specific architecture, it's our COM-Express module, AMD Ryzen 8000. And on this module, like, there is very powerful iGPU, but still, it's not what you will get in a data center. It's not the same power consumption. It's not the same processing power. So for that type of processor, we already need to quantize the model, so to reduce basically size, to compress it, that we can actually run it fast enough on this type of processor.
And I think we have talked about the telephone box on one of our previous episodes. I will just put the link into the show notes for our listeners who have not listened to the previous episode. Can you explain what that use case was about? And I think you also have a video from Embedded World. I think I will also put in the show notes, but maybe you can describe a little bit what that use case was about.
So it was to demonstrate how we can link different type of AI models to create an end-to-end experience for a customer. Like, instead of talking to a real person, basically you are talking to an AI bot. And to do that, we are using one model to do the speech to text. So transforming your voice into some text, which was developed by OpenAI, which is called Whisper, and that we are running on the processor. Then we have a large language model, which is basically the brain of the system, and that we customize for different type of persona. So with Michael, we had like one Texas Ranger, one guy in the future. So we had a couple of fun persona just to demonstrate the concept. Then we have a database attached to these people, technical specialists for Tria Technology products, and we have a database of all our products, so which means that when the AI is going to look for some information, it's not going to invent things. I guess you heard about the bad stories about AI starting to invent new information because it was just trying to please the end customer. In that case, we absolutely wanted to avoid that. So we have a database attached to the AI model just to make sure that it's not going to invent new information.
So he has to check back with a database if the information it's giving is correct.
Actually, it's taking as an input the information from the database, and then we set up the model in a way that it's not supposed to, I was about to say lie, or in a nice way, invent new information. So you have that notion of temperature, and the higher the temperature is, the more likely the model is to improvise, which is good because then you're going to have more interesting discussion, or it might get funny, or like, then it has a bit more of its own character. And the lower the temperature is, the more it's going to be boring, but the more it's going to be accurate in terms of what it's answering to your questions, basically.
What temperature? Sorry.
So it's one of the, like, when you start to work with large language model,
Yeah.
You have a lot of parameters that you can use to customize basically how it's going to react to your request. And it's all about probabilities. And one of these parameters is called the temperature of the model.
Okay.
And
Got
this temperature, it's very interesting. And if you use ChatGPT, I don't know actually if it's for like the public, but quite often actually that's the setting that you can change, or that's the most common setting that you get access. And then you can change that setting and you can improve, basically, the more you increase that temperature, you're gonna improve the possibilities for the model to come up with original ideas. So for instance, if you use LLM to do creative writing, then you want to have a very high temperature for the model because you want to make sure that it can actually invent interesting things. If you want to have a large language model for technical questions, like for technical specialists,
You don't want that.
you go rather close to zero and say, no, you please do not improvise. Do not invent that module with a brand new processor that
Keep
doesn't
it cool.
exist. Keep it slow down tiny little bit.
Okay.
And that's the temperature that you...
I didn't know that. Thank you.
This is also like, for example, with the telephone box, when we had the avatars that you call back to the past or call to the future, that they are very creative and inventive. So the temperature is higher on that one. But if you ask questions about Tria products, it need to be correct. So you will not put a high temperature there. And it's the same in the direction that you have what we call hallucinations. If this is too high, it can create also easier hallucinations so that it goes in a direction that you do not want. So it depends on the application, how you set this or you change this parameter.
Speaking of applications, I can see service hotlines, customer service desks, information if I'm in a city. They used to have it in the airport where you can talk to an avatar and it would give you information on the city you just landed in, stuff like that.
It can be. Cedric mentioned also something like vision related, but initially we started, in fact, more the text-based models where you have applications like a kiosk or you arrive in a hotel, you can check in, ask questions. For us, what was quite interesting is if you have applications like conference systems and so that the conference system can have an interaction with the participants in the room, can translate, for example. But this can be critical if you have, where it's very confidential what is said. So to have this locally and not running in the cloud, not to send the data to OpenAI, for example. So this was one of the triggers we had to do this kind of implementation. But of course, in the meantime, you see that there are much more applications also related to vision in combination with audio. And this is the trend that we have now. So it's not only text-based, it's not only like conference systems, kiosk, but also applications.
Yes.
This is something that will be very, very interesting for the near future.
Okay. So exactly that's what is next on my list of questions I want to ask you. Which industries are moving fastest with this? And especially with the OCR use case you just mentioned, what is it about?
The use case is about, in some industrial context, when you are printing, you need to make sure that the output of your printing is 100% accurate. It's one of the requirements. And there are companies that are specialized, for instance, in developing OCR systems that are going to check that the output of the printer is going to be 100% accurate compared to what it was supposed to print. And that's a real use case that we've been discussing with customers, for instance.
You mentioned conference rooms as a use case, so security relevant use cases. Walk me through some more of those examples.
Well, you can imagine, for example, robotics or security cameras, for example, and even also where you traditionally had vision implementation, so with convolutional neural networks, that you can do this also with generative AI and have a combination of, for example, you detect what you see on the street, but also can ask questions, what happens on the street, for example. If there was an accident, when this accident happened. So you will see more and more this kind of combined views. It's not purely then vision, it's also an interaction you have with the camera. So those are applications that we will see more and more, like related to cameras, vision, robotics, where you not only have the interaction with the robot, but also the understanding what the physics around the robot is, that he knows what is happening. Yeah, those kind of applications, this is typically what we discuss today with customers.
I mean, it's what's going to happen. So that's really brand new, I would say. And that's going to take a couple of years before it gets to the industry, just to be clear. There are two new type of models actually that are becoming more and more popular. One is for robotic arms. So that's a new type of, should not be called large language model anymore because it does not make much sense, but it's the same type of architecture, but it's for the movement of the arm. And basically, you are explaining what a robotic arm should do. So instead of training computer vision, having some logic to pick up, I don't know, the red blocks and to put them in the blue bin, you just write a prompt and you say, please pick up the red blocks and put them in the blue bin. And that's brand new, this type of large language model, what you can use actually to control the robotic arm, because there is nothing in between. There is no logic anymore. It's just the AI model that is actually taking control of all the sensors, all the actuators that are in the robotic arm, and then targeting the move. And I've seen like some demonstration and a Hugging Face that is the go-to platform for this type of AI model today. And they develop basically an open source robotic arm and developing a framework and a lot of things around that, which is, since at least the CEO of the company is French, they call it le robot for the robot. And I've seen that they were using it, for instance, to fold some laundry, which is super hard. Like you do that on your bed. You think, okay, yeah, and what? But for robotic arm, very thin motoric skills to do that.
Wow.
Super impressive. And it's coming. And there is another trend, which is with time series. That when you are looking at a factory, basically a lot of data that are coming from the sensors of the factory are time series. And I think it's coming from Stanford in the US. They develop a new generation of, again, I call it large language model, but the name is a bit wrong there. Let's take a real world example. Your heartbeat. Like you don't feel so good, and so you go to the doctor. They're gonna do some measurement of how you're breathing, your heartbeat, all the information about what's going on in your body, basically, and they're gonna look at it. This new generation of LLM, they can take as an input, in addition of the text, basically time series. So time series, it's gonna be the recording of your heartbeat, and they can then tell you, okay, like potentially the issue that you have is that, and that. I mean, AI scientists, they are trying that with health data. So far, they always failed. Just to be clear, Google invested a lot of money into that for a long time.
Okay.
But this type of model, it's the first time where it actually looks good. It looks like it could be a good assistant. It will never replace doctors, but it could be a good assistant for doctors, that it's actually gonna give them a good hint in terms of what's happening for that specific person.
What, in your opinion, is the biggest technical hurdle that you now still have to overcome?
I would say power consumption. I mean, everybody talks about that.
Sure.
When you use ChatGPT, it's really bad. Right now, these AI models, they are still mainly running on GPUs, which are extremely power hungry because they are good at doing it, but use a lot of energy. But it's changing. Like companies like Qualcomm, they have been investing a lot of money that we can run these models on NPUs, neural processing unit. And you might wonder, why is it any different? Because NPUs, they are specifically optimized to work with those quantized values. I mean, GPU, they can do it as well. And they are specifically optimized to have a very, very low power consumption, which means in the future, we will be able to run this type of AI model on NPUs and with a very, very low power consumption. Which means that when today you use your mobile phone to run one of these models, it goes to the cloud, and then you get your answer back, which is really bad for the environment. But with the next generation of NPUs that we're going to have on the mobile phone, that will not go to the cloud anymore. It will just stay locally on your mobile phone using very little energy compared to what's happening today, and you will get my answer about what the heck is that vegetable.
And looking ahead, what do you think, when will we reach cloud quality performance on embedded devices?
Still gonna take a couple of years. Do we need it?
We do not always need it. It depends on the application, of course. You need to have a high-end system that knows everything if you only have a specific task for it. So it depends on the application. But
Okay,
of course,
makes sense.
what we will see is that many companies, like for example Qualcomm, but there are also companies that develop dedicated chips for generative AI or for CNNs, for example. We will see that those will come with chips, very low power consumption, but yet that you can integrate in your application and have a quality of a kind of, I would say, ChatGPT of today, and you run it within 2 years on a chip. This is the trend that we will see.
Okay.
And of course, this is also what we will focus on to support our customers for this kind of higher-end applications, but even on chip level, can be then integrated in the processor or can be as an external NPU, so neural processing unit, to build the application.
And for engineers considering exploring local language models, what's a piece of advice you would give them before they start prototyping?
It's extremely straightforward. They should use llama.cpp. So that's a framework. So you can find it on GitHub. I mean, there are plenty of other options. Sometimes, for instance, Qualcomm, they have their own libraries for that. NXP, I know that they are developing the same. But .cpp, it has been developed by the community for the last 4 years. We have been using that from the beginning. Qualcomm participated to the project already to optimize the implementation that is running on their embedded GPUs. So it's super well maintained. It's like you have all the algorithm ready for you and the models pre-quantized that you can find on Hugging Face. You have all the tooling to retrain some of these models, because when you use a very small large language model, ultimately what you end up doing is still to retrain it for your specific use case. If you want to have a good accuracy in terms of output. And so all in all, I would say llama.cpp if you are looking into large language model running locally on embedded devices.
Okay.
And maybe not starting with too complex implementations, because many customers, they think they need to have the best hardware to learn and to have the best models, and then they buy expensive GPUs. They want to run 70 billion parameter models and then start testing. But it's in fact not really needed. They can do this through the standard models in the cloud. But this happens a lot, that people want to start with the best and the most expensive, but it's not really necessary in my point of view.
That's great advice. Thank you. If you had to pick a song for the soundtrack of this episode, what song would you put on it?
Okay, so we discussed that with Mike. I would like something with the llama, but I could not find anything, unfortunately.
I Googled llama songs and I came up with very interesting songs.
Yeah, but that's why, okay, we found songs, but
Okay. I think this is like a children's song, the llama song.
Yeah.
That's
more
what I
you
found.
find when you're looking for llama song.
Okay. So we should not put that on the playlist?
I mean, I'm up to it.
Okay. Let me see. What do you think, Michaël?
Well, indeed, Cedric, we discussed, and llama, for example, or llama.cpp, it does not come from the animal. They use the animal as a kind of icon, but it means completely something else.
Oh.
But to find a song about it, I don't know what the best one would be.
Maybe we have to ask our listeners what song they would put on the playlist and see if they have an idea and some feedback.
Well, another option is, of course, you can ask a generative AI model to generate a song. There are several possibilities now. Oh yeah, like with 11 Labs, you can do it with Suno. I think it's Suno. You can do that. You put in the text what you just asked. Can you create me a song about a llama and it need to be related to llama.cpp? Let's see what comes out.
Maybe I should give that back into your hands. Because you will
can
then...
do it.
Okay. That's a first. Having the song composed by generative AI for the playlist. I love it.
Okay.
Let's see if we get something together then.
Okay.
Michaël, Cedric, thank you so much for being on the show. It has been fascinating to chat with you about local language models. Thank you for being here and sharing your expertise.
Thank you, with pleasure.
Thank you for the invitation.